All right, course 2, lesson 33, comparing decimal numbers. All right. Can't write today. All right, so let's take some decimal numbers and let's rearrange them in their correct order. And a way to help us do this is when comparing decimal numbers, we have to consider their place value. We learned place value a couple of days ago. The value of a place is determined by its position. All right, well, there's someone at the door. So anyway, when we're comparing decimal numbers, it is necessary to consider their place value. We need to make sure their place value is right with respect to where it is at the decimal point. Notice that this one, the 3 is in the hundredths place, the 8 in this one is in the thousandths place, and the 5 in this case, the 5 is in the 10,000ths place. So we need to consider that as part of it. A good way to help us do this is to align our decimal points. So let's rewrite these, aligning our decimal points. Okay, so I lined up all my decimal points, and this is where everything lines up, right here. So we can start to really eliminate things. Let's look at the tenths place. So the first two have a decimal in the tenths place, while the third does not. So really, we can quickly see that this one is our smallest one. So if I'm writing these smallest left to right, my smallest one is right here. Now, how do I know the difference between these two? How will I find the difference between those two? And the easiest way to do that is to fill in the gap with a 0. And you can ask which one's bigger, 130 or 128, since they're both tenths places away. And of course, 130 is bigger. So my next smallest one is, and then I finish off with 13 hundredths. It's bigger than 128 thousandths. So that is a clue for us to help us solve these. And when I write it, I just actually would not have that 0 there. All right, so we could do all kinds of things with that. So if we need to compare the difference between these two numbers, and believe it or not, a lot of people get tripped up by these. So you can see the 12s and they're equal, but they're not. So let's make sure, let's line them up. Okay, lining them up, you should be able to quickly see that one is bigger than another. But even if you can't see it, adding that 0 there should really make it clear that there's a size difference in those numbers. How about 1 and 232 thousandths and 1 and 23,185 hundred thousandths? Which one is bigger? Again, they're pretty close in the same size. Even adding those zeros, you can see that there is a size difference with these. And you would write your answer just like that. Okay, we can do that when we're rounding decimals as well. Let's round this one. Let's round this one to the nearest hundredth. Well, if I round this one to the nearest hundredth, then my hundredths place is right here. Here's my hundredths place, right there, that 4. Well, the number after that, again, remember with that rounding rule, the number after that is a 1. And with the rounding rule, if it's less than 5, we will stay the same. So, or sometimes round down, depending on what's going on. But this case, we're just rounding to nearest hundredth, so we'll stay the same. So I end up with 3.14, or 3 and 14 hundredths, or pi, because that's what pi is. Let's try another one. Lest you get confused, let's round this to the nearest 100. Okay? Well, the nearest 100, we're talking about this 9 over here. And in that case, since we're talking about that 9, got myself going for a second, I made a mistake. So I need to take a break, take a pause. Look, I made a mistake. Here's my 100th place right here. 100 place, I keep saying 100 because I'm just talking about decimals. That's where you get tripped up. So my 100 place is a 3. My target number is the one after it. That is definitely 5 or more. So I need to write my number now that's going to make my 3 go up. So I get 4,400. The rest of it is blank because it's not necessary. So we can use rounding to help us solve different things. So if I had two numbers and I was multiplying my two numbers and I want to estimate it, well, since I'm estimating it, I'm going to round each number, and let's round each number to the nearest whole number. So that's going to give me 12 because my nearest whole number, here's my target. The number after it is less than 5, so it'll be just 12 times. Now here's my target number, the 4. The number after it is 5 or more, so that's going to round it up. So 12 times 5, which equals 60. So go ahead, give a shot to all the practice problems on page 238.